Hey, hi guys, in this video I am going to show you how you can detect any features on the satellite imagery using deep learning. So go to your favorite browser and search for the browser.dataspace.copernicus.eu to download the satellite imagery and log in with your own credential. Here I am logging with my email and the password. Hit over the login button. You get the interface of the Copernicus browser like that, and go to the data source and select for the Sentinel-2, and I'm downloading the Sentinel-2A imagery. You can go to the draw the area of the interest. You can either draw the area of the interest go to the rectangle section and draw the polygon over the area of the interest. You can draw like to make the area of the interest. You can actually interactively draw over the area like this. Okay, and yes, draw the perfect. And if you want to upload the KML file or SAF file, something like that, you can upload from the KML or the SAF file. Here I am uploading my own area of the interest. Here okay, click over the open. You can see here and go to yes, go to the source. In the source section you have to select your own data set and you have to select the time range. I am selecting the 2025 420 22 520. Yes, no, okay, from the January 22 to March 15. Yes, let's select the date range and let's see whether the data is available in that range and at this date. Yeah, it's available here. Okay, go to the download section and download. But I think look at the imagery. I think there is a cloud content in the imagery because we haven't we have filtered the cloud cover up to the 27% before 7%. Let's check the other imagery that are available for this region without cloud or not. I think we don't have an image, so again go to the source section and let's expand the date to 2024 to 2025. Yes, okay, go to the 2024. Okay, perfect. January 1st to yes, and drag the cloud cover percentage to up to 5% or 6%. Okay, perfect. And yes, go hit over the search button. I think we have the couple of the imagery without cloud cover is present at this time. Yeah, we have the two imagery at this region. Click over the download button and you can download the imagery. I'm going to download the first imagery here, and for first imagery in this video I am going to actually downloading the two imagery, right? One for the training purpose, and I am after the model get trained I will apply this model to detect the totally different area. So I am going to download the two different imagery, and okay, this imagery get downloaded. I go to the download section and you can see the downloaded imagery. And go to the another totally different region to test the whether the model working perfectly or not for the not in the new region. Again hit over the download section and you can see the download get started. And okay, and wait until the image get downloaded. You can see 100% in my the download bar. You can see both of the imagery are present in the download section. Let's rename to one image for the training and the one imagery for detection. First imagery, I am using first imagery for the training purpose to train the model, and second imagery to detect the model. But actually you can detect we can use this model to detect the features from the any of the world, right? Okay, I'm just extract the both of them, training and detection, WinRAR, and extract files, extract with the same name, so that you can get the same. Yeah, and let's delete both of them. I do not need any of the name. And I have training and the detection data set. I'm going to train the model using ENVI software here. But yeah, if you go to inside Imagery, you can see all the different file ascending in proper structure. Go to the, and here you have to go to the search and search for the ENVI 6.1. I am using the ENVI 6.1 model deep learning features to train the model. So at first go to the data manager tab and open tab, and go to the OK. At first we are opening the training data set, mtd mst. Yeah, source this file .xml file. It contains all the metadata, so that the Sentinel-2 imagery is visualized in proper way. You can see here the different cotton fields with different. Yeah. Okay, let me predict on the cotton field. Okay, the cotton field, I think cotton field is too much easy, so I think I changed my mind to detect the water field, right? So you can see all those water ponds here. So let's train the model to detect water here. So let's make the vector file. Go to the file and go to the vector section and give the name to the water. So we have to collect the data at first to train the model. So let's collect the data in the save file. If you already have the save file of the features that you are going to detect, then you can easily apply. I don't have any data set, so I'm going to create the data set of the different data set of the water ponds. You have to digitize all the data set, all the every single. You have to digitize every single ponds or features we are going to digitize. Here I am going to digitize all the ponds in this field. So the model works perfectly fine. It is working perfectly. Yes, and okay, it takes sometimes. Let's wait until we completed the data collection. Yes, I think some of the reasons are already are still missing, but I digitize the sufficient data set. So I'm going to save this save file in the some folder here inside agriculture DL. I am making one folder here. Name is water detection. Yes, and inside the water detection I am going to save the water.save file, .ssv file. And if I if I remove the let's check the data is saved or not. You have to remove both. Just remove these from data manager also, and go to the open folder and open the same folder you have saved the data set. I am keep inside the agriculture, inside deep learning, water detection, and here you can see the water.ssp. It's perfectly saved and we are ready to train the model. And okay, we have to make the label at first. So go to the deep learning section in the toolbox and go to the deep learning labeling tool. Open the button, and I am detecting only one feature, but you can detect multiple. File and the new projects. Here give the name to the project name water detection, and the project folder to inside the water detection. Let's make another for water detection. Yes, there is a water save file here. So let's make one folder inside the water detection, and deep learning water detection, and make the one folder that is name is labeling. And yes, perfect. And go to the at this time go to the new project and project name to again water detection, and go to the browse tab and give the folder to the labeling section and hit or enter. And we are going to detecting only one class, so I am going to create the only one class that the name is water. And you have to select the raster. I am using only the 10-meter resolution Sentinel-2 imagery, and hit over the draw button. Okay, and you the ROI section to draw the section automatically import, and go to the file, import, and import the vector, and import all the vector from vector. Yeah, it automatically label the raster using those vector files. We have already labeled the one vector, but label raster doesn't create it yet. Go to the train section, and it calculates all the raster statistics, and also the pyramid, to make the, you may know that the stretching value or something like scaling some, and it is creating the label file for the training section. Okay, now our model is ready to train. If you have the more GPU in your computer, you can give the patch size large, but my GPU is not so good, so I'm using 240 size. Larger is faster, but use the more memory. That you can see in the you have to train the model with at least 100 epochs, or the, if you need high accurate, you can also train the model with the 500 or something like that. And and at the model output, you have to give the extension.h5. We are going to train the model with 25 epoch with a model name water.h5. Okay, and our deep learning model start to train the model. Yeah, you can see all the, it includes the all my past work as well as this data. So you can see all those loss function, all those loss and precision, FN score, all thing in this those TensorFlow board. My model is start to train. You can see here already 14, 15 epoch, 16 epoch, 17. I think it takes time to train the model. Yes, you can see here the TensorFlow boards, all things to perfect. All things seems good, and you can see my perfect model here at the last. Here our training is all completed, and go to the we browse the folder where we saved our train model, that is .h5 format. It is actually the Keras format you can use in other library tool, right? You can directly use those water.h5 format in other platform, like open source platform, like in Python or something like that. We close all these training set. Now we import the detection totally new imagery, that is the detection. We open the same like that. We open the .xml file. It automatically import all those dependency or something. Search over the region. Here you can see all those points, and let's try our model whether it can detect the points or not. Input the training raster, that is the same as the input raster, that is the same size as input raster in that for the training. And let's import our train model too. Go to the water detection labeling, that is, you can see water.h5 model. Hit the open and give the name to the classified. We are going to classification of the raster. So okay, let's name to the classified and hit or save, and that's all. All thing, yeah. Bands 4, that is RGB plus NIR in this band 2, 3, 4 and 8 of the Sentinel-2 imagery. And it calculate and it calculate the histogram, something like that, and it export zeros raster at first, and it assign the value after the pixel get trained, right? You can see if you after you train the model, you can see all those classes along with the unclassified raster, because at beginning it export the unclassified, all those pixels with unclassified, and it classify after it apply the model here. And after, I think the model we detect all those pixel in the model. Yeah, you can see all those water pixel here. Okay, let's zoom whether our water detection model works or not. Yeah, let's zoom over the region. Okay, all these pixels, yes, I think these are the water pixel. Yes, our model works perfectly fine here. This is the model. Yes, this is perfect. Thank you.